Good morning, guys. We're going to be covering section 12.4, Mass-Mass Stoichiometry today. And of course, all of this comes from your CK12 packet. Our introduction talks about walnuts, right? Let's say, your aunt, your mom, your grandma, your grandpa, they like walnuts. And for some reason, they're asking you to go get them 250 grams of walnuts. What you gonna do? All right. Who's gonna help me read?
I want to send 250 grams of peeled walnuts to a friend. Don't ask why, just go with the question. How many walnuts and shells do I need to buy? To figure this out, I need to know how much the shell of a walnut weighs. About 40% of the total weight of the unshelled walnut. I can then calculate the mass of walnut that will give me 250 grams of shelled walnuts and then determine how many walnuts I need to buy.
Thank you, ma'am. So you know a couple of things. You need to bring home a total of 250 grams of shelled walnuts, right? You know also that 40% of the total weight of the unshelled walnut, uh, 40% of the total weight of the unshelled walnut. So the shell itself is only 40%. So 60% is the walnut itself. You need to do some quick thinking and be like, okay, well, 40%, so that's 60%. And so you're gonna be doing some math. And either eventually you're gonna figure out, okay, well, each walnut weighs this much. So I need to divide, 250 by that, and then you get your answer as to how many walnuts you need to grab. That's, kind of similar to what we do in stoichiometry when we're doing mass to mass calculations. And technically, you did it yesterday. You did it, but you did it in parts. You did it mostly because in the first sample problem, we did mass to mole problem, right? And in the second example, you did moles to mass. Well, today we're going to connect it. We're going to start with compound A, the mass, right? The grams of compound A. We're going to change grams of compound A to moles of compound A, right? Once we have moles of A, we're going to switch it to moles of B. For moles of B, we're going to change it to grams of B. And that's already something that you already did yesterday, except you kind of did it in parts. We didn't do it all in one problem. Today, we're going to do it all in one problem. And it's going to look complicated, it's going to look confusing, but the more practice you do, the better you get at it. So mass-to-mass calculations are the most practical of all mass-based stoichiometry problems. Moles cannot be measured directly, while the mass of any substance can be generally measured in the lab, right? We can go into the lab and we can figure out, okay, how many grams are you using of sodium chloride, right? But I can't do it, or I can't go and be like, okay, let me figure out the moles of sodium chloride. I can do the math and figure it out, but I can't use a device and it spit out, okay, you have 2.5 moles of sodium chloride. There's no way. There's nothing in chemistry in our laboratory that will do that for us. We can only do it on paper with calculations. This type of problem is 3 steps and is a combination of the 2 previous types, right? Yesterday, we did mass to moles, where we used molar mass in step 1 and then mole ratio in step 2. That's the first part of our problem. We did that yesterday. You know it. You became very, very familiar with it. Today, we're going to start with molar mass, mole ratio, and then molar mass will be step 3. So step 3 is not something new. It's something you already know. You're just going to apply it in a different way. So remember, the mass of your given is like saying grams of compound A. Then you're going to use molar mass to change grams of A to moles of A. You'll use mole ratio to change moles of A to moles of B. And then you're going to use molar mass again to change moles of B to grams of B. And that's exactly what the paragraph at the bottom says. The mass of the given substance is converted into moles by the use of molar mass. We said that. Then the moles of the given substance are converted into moles of the unknown by using mole ratio. We just said that. Finally, the moles of the unknown are converted to mass by using molar mass. All right. What are the 4 steps involved in mass-to-mass stoichiometry? And don't worry, I got you. Let me just go to a blank page. Okay, if I'm doing mass-to-mass stoichiometry, so that means I'm doing mass to mass stoichiometry. What do I always start with? I start with my given, and my given today is going to be mass of compound A. I'll start it off for you. So that we start off with mass of A. So technically that's grams of A, right? And what did we do yesterday? What did we change our grams to? What did we change grams to yesterday? Remember?
Moles.
We changed it to moles of A. So then we're going to put here mole of A. Mole of A. Okay. And then step 3 is the same as yesterday. What did we change moles of A to? Remember, we use mole ratio. We use the balanced chemical equation and we switched A to what? What did we switch? We went from moles of A to moles of, what do we call it? What's the next letter in the alphabet? Moles of A became moles of
B.
Correct. Moles of B. And we did that with mole ratio. Okay, and now we're just going to add a 4th step, or a 3rd step actually, right? Because this is 1 step, this is 2 steps, and this is 3 steps. So now once we're in moles of B, remember we have to end in mass, but no longer of A, mass of what letter?
C.
Try again. We're not changing it. We're only going from A to B. So once we start with mass of A. We go to moles of A. From moles of A, we go from moles of A to moles of B. And the last step is just going back to mass of who? B. Okay? So here and here is molar mass. This will be molar mass of A. This will be molar mass of B. Step 2 will still be the same. It's still mole ratio. That's where we switch from A to B, depending on what they ask us for. All right, so that we answered that question. Now we know the plan. Now we need to put it into action. Here is sample problem number 1. Ammonium nitrate decomposes to dinitrogen monoxide and water according to the following equation. In a certain experiment, 45.7 grams of ammonium nitrate decomposes. It's breaking down, right? We know that. Find the mass of each of the products formed. Oh, I hate these type of problems. I don't hate it. It's not my favorite because not only do we have to do stoichiometry for one, we actually have to do stoichiometry for 2 of them. So we're still, hold on. Oops, let's go to Jamboard. All right, so here's our problem. Well, let's identify what we know. We know that we have 45.7 grams of ammonium nitrate. This is ammonium nitrate right here. The question that they're asking us, and I'm just going to underline it or circle it, whatever, is the mass of each product. There's more than one product, so we're going to have to do more than one calculation. The only good news is that step one repeats for both of them. In step one, I still need to change. And remember, this is my A. This is my B. Step one is all about changing grams of A to moles of A. So technically, step one repeats. So whatever answer I get for step one, I'm just going to copy it when I do the second one. All right? But let's do it first, and then you can see what I mean by that. So remember, the first step is always to use the molar mass of A to convert grams to moles, right? So that's what we're going to do first, and it's always dividing. So we need to find the molar mass of A, and the molar mass of A, I believe, was NH4NO3. So this is my compound. My elements, and remember, molar mass is all about listing the elements, counting how many there are, multiplying by the atomic mass, and then adding up, right? Those are your 4 steps. Make a list, count how many there are, multiply by the mass, and add. So we have nitrogen, hydrogen, and oxygen. How many hydrogens? How many nitrogens? How many oxygens do we have? Can you guys tell me that? Help me out. How many nitrogens? I see 1 here. I see a total of not 1, Miss Diamond. There's actually, remember, there's 1 here and there's 1 here. 2. Very good. How many hydrogens? What's the number after the H? How many hydrogens? 4. How many oxygens? What's the number after O? Very good. 3. Well, we know oxygen. Oxygen is one of those that we use all the time. It's 16. Hydrogen, we used it yesterday. We said it was 1.01. And the only one that we really need to look up is nitrogen, because we haven't used that one lately and I don't remember it. Technically I do, but I need to show you how to do it. All right, on the periodic table, group 15, period 2, you'll find nitrogen, right? Element 7. It's got 14.007, which rounds to 1401. Shotgun. I'm going to do the calculation for hydrogen. You guys do nitrogen and oxygen. I always do the easy one. All right. Done. What is the mass of nitrogen? What's the mass of oxygen according to your calculations? 2 times 1401. 3 times 16. Can you give me the numbers? Hey, Oscar. Joining us a little late today. All right, Oscar's here. Kevin, I already marked. Okay. Okay, nitrogen is 28.02. Did somebody do oxygen? What's 3 times 16? Jeremiah, Melissa, Alexia? 48. The last step is always to add them up. I know my unit, it's grams per mole because it's molar mass. So add them up. 28.02, 4.04, 48. What do they give me? What do they give me? Oscar, what do they give me? Get your calculator app out. I know the answer, but I need you guys to do the work. 80.06 is correct. All right, so that's the molar mass of this compound. So we're going to go back into the last slide and we're going to divide. We're going to take our 45.7 grams and we're going to divide. We're going to divide it by 80.06 grams per mole. And it's going to give you a number, 0 point something. A little bit more than half, I believe. A little bit bigger than 0.5. What do you get if you divide both of those? Shh. I'm teaching here, bro. There it is. 0.57 moles of NH4NO3. So now that's step 1, molar mass of A. So now we're going to do step 2. And step 2 is always mole ratio, where we switch A to B. And you have all the information you need. It's right here, right? You're going to look at the reaction and you're going to see, okay, well, how many do I have of each? But before we do that, we need to set up our dimensional analysis. And don't forget, there's always an arrow to remind you that moles of NH4NO3 need to cancel. So then that means moles of B need to go on top. What's the coefficients? What's the number, Oscar, that's in front that you don't see? Right here. What's the number in front that you don't see? For both of them. What's the imaginary number here? 1. 1 over 1, right? 1 over 1. So what happens if you multiply by 1 and divide by 1? 0.57 times 1 is 0.57. Divided by 1, 0.57. But now we've changed it. It's no longer 0.57 moles of ammonium nitrate. It's now 0.57 moles of N2O. Step 3 is always molar mass of B. Okay? And over here, you divided it. Here, you will multiply. Okay? So I know I need to multiply by the molar mass, which the unit is grams per mole, but we need to figure out, well, what's the number? What's the mass of N2O? So we go to the side, right? We go to a new page and we figure out, okay, I have N2O, right? What is my molar mass? So then I put nitrogen, I put oxygen, I put 2, I put 1. We already know the mass of nitrogen is 1401. We already know the mass of oxygen, it's 16. And then Ms. Diamond earlier said that 2 times 1401 is 28.02, right, Diamond? So the only thing left to do is to add them up, right? We're not going to do extra work when Ms. Diamond already did the math over here for us. We're just transferring the information. Okay, add them up. 28.02 plus 16. And of course, I already know the answer. I can tell you, the unit is grams per mole. Thank you, Ms. Diamond. 44.02. That's the molar mass that we're going to multiply the answer to right here. 44.02. Multiply it. What do you get? 20 something. I know it is. What's my answer? 20 something. What's my answer? And of course, oops, I'm already going to mess up. It's grams of N2O. There it is. Very good. 25.09. And we're done. Okay? But that's just for one product. We're supposed to do two products. So guess what? We're going to go over here, and now instead of, we're going to switch this guy to water. This is still my A, but now my B has changed. Now I need to do or convert to mass of water. Step one was the same, right? Step one was using molar mass of A to change grams to moles. So that repeats. I'm just going to copy the answer that we got. And I believe it was 0.57 moles of NH4 NO3. And remember, step two is mole ratio, where we change A to B. So we set it up. We write times and then a line, and then we draw the arrow. That's supposed to be an arrow. Don't look like an arrow. Okay. So the arrow helps remind us that moles of NH4NO3 needs to follow the arrow. So then that means there's only one place for moles of B to go. And our mole of B is H2O. So my question to you is it 2 over 1 or 1 over 2? Where do these numbers go? The coefficients, the numbers in front. Where do these numbers in front need to go? 2 over 1. Very good. The 2 needs to stay with water. So it's going to be 2 over 1. So what do we do when the numbers are both on top? We multiply, right? We multiply 0.57 times 2. What do we get? Oops. 1.14 moles. And now, all of a sudden, we have water. The third step, again, is still the same. We're going to use molar mass of B to change moles to mass or grams, right? So I know I need to multiply by the molar mass of water. So I'm going to do my setup. All I need now is to go again to our scratch plate, our scratch page. And now we're going to do another molar mass, but this time we're going to do the molar mass of water. And that's an easy one because it's just hydrogen and oxygen. Hydrogen, we have 2 times 101. Oxygen, 1 times 16, which of course I can easily do is 16. 2 times 101, that's some easy math. I can do it for you. But what's my molar mass? Add them up. And technically I can do it for you too, but I've been doing a lot for you. You guys do it. Come on, Oscar. You're quick with math. What's 2.02 plus 18? Or Jeremiah. Jeremiah's quick with his math too. Melissa's good too, but I don't know. How you feeling, Miss? 18.02. Very good. So that's your molar mass of B. So we're going to take it back to our slide. We're going to input the 1802 and we're going to multiply. 20.02, that's what you got, sir? I got something a little bit different. So it's grams of water. I got, yes, that's what I got, Miss Diamond. 20.54. And we're done. It's not super hard. It's just usually the big complaint is I hate doing the molar mass twice. And it's understandable. Look at all the work we did because of molar mass. Look at all this extra scratch work. And that's just for this one, you know? All right, let's look at the answers that they got. Okay, according to them, they ended up with 25.1 grams of N2O. I think we ended up with 25.09, which is very similar. They ended up with 25.1. We ended up with 25.09. I think they just rounded. We didn't. For the second problem, the second question, they ended up with 20.6 grams of water. I believe we came up with 20.54 grams of water. Again, they probably rounded. Okay. Either way, very similar answers. All right, this is the last example that we're going to do today. What mass of barium phosphate can be produced from 14.3 grams of potassium phosphate reacting with barium nitrate? All right, I already have this here. All right, let's circle our information so we know what we're looking at. All right, we are starting with 14.3 grams of potassium phosphate. And we're going to change it to mass of barium phosphate. So potassium phosphate, that's this guy right here. So this is my A. Barium phosphate, this is my B. So now that we know who's compound A, who's compound B, we can go through the 3 steps. The first step, divide by the molar mass of A. The second step, do dimensional analysis for mole ratio to change A to B. Step 3, multiply by the molar mass of B. Those are the 3 steps. Very easy steps. It's not super complicated, time consuming, but not hard. Okay? So what do we need to start off with? We need to find out how much potassium phosphate weighs. So we're going to go over here. And we're going to do K3PO4. And we're going to find out how much it weighs. KPO. Okay. Potassium, we can easily see there's a 3, phosphorus a 1, and oxygen a 2. Do you guys agree or disagree? You should agree, technically. Oxygen, we know, is 16. So I already wrote it down. We need to figure out potassium and phosphorus. Potassium, group 1, period 4. Element 19, 39.098. So that's going to round to 39.10. Phosphorus, element 15, group 15. It's over here on the right, 30.97. Everybody see it? 30.97. All right. I know phosphorus. That's the easy one, so I got it. How much is potassium? Oxygen, I can probably do it in my head. 16 times 2 is 32. 32 times, multiply that by 2, that's 64. That's easy math. I can do that one. But what about potassium? I can't do that one in my head. Way too much. The numbers get way too big, guys. I need your help. 3 times 39.10. What am I looking at? Thank you. 117.3. And if we add them up, Oscar, what do we get? Jeremiah, haven't heard from you lately. 200 and something. What is it? 200 and something. What is it? Yes. 212.27. So we're going to multiply by that number. Divide. 14.3 grams. And it's going to be a very small number. 212.27 grams per mole is going to give me 0.0 what? What am I looking at, guys? What's my number? Oscar, Jeremiah, Alexia, if you divide those numbers, what do you get? 0.67, isn't it? There it is. And then it's going to be of K3PO4. So step 2 is all about mole ratio. We're going to change A to B. And we already know what A is and we already know what B is. So I'm going to put times and then a line and then draw the arrow, right? Moles of K3PO4 need to follow the arrow. So then that means B needs to go on top. Moles of BA3PO4 with a 2. Okay, 2 over 1 or 1 over 2? Where does the 2 need to go? Look at the reaction. Check it out. Oscar, where does this 2 need to go? Where does this 1 need to go? Is it 1 over 2, Oscar, or 2 over 1? What do you think? Miss Diamond is saying 1 over 2. Do you agree with her, Oscar? Does the 2 go on bottom? That young lady is correct. Yes, the 2 goes on bottom, the 1 on top. So that means this number needs to get divided or multiplied by 2. What do you think? Divided or multiplied? If it's on bottom, remember, mathematically that means to divide. So if we divide, what is my answer? I know I'm going to have moles of Ba3PO4 and a 2. If I divide 0.067 by 2, what do I get? Very good. 0.034. And my last step is to multiply by the molar mass of barium phosphate. So I'm going to go over here and I'm going to put barium Ba3PO4 with a 2. So that means BaPO. I know barium is a 3. What about phosphorus and oxygen? How many do I have? 2, right? There's 1 on the inside, but we have to multiply by 2. How many oxygens? 4 times 2? How many? If I have 4, multiply by 2. 8. Very good. So now we need to multiply. I know oxygen, because we always know it. I know phosphorus, because we used it in the last calculation. Barium is the only one I'm going to look up. 137.33, element 56 at the bottom left corner. 137.33. Okay, let's get our calculator out. I know you have it close by. Oscar, do oxygen. Diamond, do barium, and I'll do phosphorus. Very good. 411.99 for barium and 128 for oxygen. If we add them up, we should get somewhere around 600. Add them up. 411.99 plus 61.94 plus 128. It should be about 600 and something. Very close to 600. Very good. That's what I got. 601.93 grams per mole. So I'm going to take it back to the last slide and we're going to multiply that, right? 601.93. So my answer will be grams of barium phosphate. What will I get if I multiply those two? 0.34 or 0.034 times 601.93. Oscar, where you at? I'm looking for you right now. 20. I didn't even multiply it, to be honest. This one, I don't remember. 20.46 or 47 if you round correctly. Oops. 20.47 grams. Very good. Oh, that was a challenge, guys. Good job. All right. Unfortunately, the answer for this one is not there, but it is correct. That's what I've gotten in all my classes. In summary, mass to mass calculations involve converting the mass of a reactant to moles of the reactant, then using mole ratio to determine the moles of product, which can then be converted to mass of product. Your review questions. If matter is neither created nor destroyed, why can't we go directly from grams of reactant to grams of product? Why is it important to get the subscript correct for formulas, and why do coefficients need to be correct?